Hello everybody! We've got another maths lesson. In this maths lesson we're going to be, I suppose, revising and just remembering some really important things. And the big thing that we're going to be talking about today is what we call inverse operations. How some operations are the opposite of or undo another one. And we're going to have a go, first of all, by just making sure that we understand what function machines are. So, in a function machine, what we do is we'll start over here. Perhaps we'll start with the input. Let me just move myself out of the way. We'll start with the input here. And our input number is 80. 80 goes into the machine, and then the machine, I've written it here, the machine will then apply a rule to that number and change it. Here, we've got a very simple rule. So it's the input number, add 2 makes the output number. So we're doing 80 plus 2 equals, 80 plus 2 is 82. And this is a very easy one, but I want to just start thinking about how we represent this, because we're going to go on to some slightly trickier examples. So we start with the input number on our number line. Number lines are really good for addition and subtraction problems. We start on the input number. We know that it's 80. And what does it mean to add 2? Well, we're going to go up 2 on the number line. And we'll get to our answer, which is 82. Count on 2. Go up 2. I'll put an arrow there to show we're going up the number line to get to 82. Okay, so not too hard. I hope we're getting the idea. We'll do one or two more, just straightforward ones. A function machine. So remember how it works. Here's the input number, 80. We have the rule. Let's see, how would it look like? Would this is not adding. This one, the rule is take away 2. So here we represent it. We say we know the input number is 80. This time we're not going up the number line. We're going down, taking away. We're counting down, counting backwards. Take away 2. Well, 10 take away 2 is 8. 80 take away 2 is 78. Okay, good. Well, we started with some easy ones just to get the idea. This is what a function machine does. Okay. Oh, look. Well, function machines, so our input now is 80. But it's not add and subtract anymore, it's multiply. It's times. So, not too hard, 80 times 4. But it's really important for today's lessons that we can represent the maths. So I want you to try and represent this with a bar model. Pause the video, have a go drawing it. What does 80 times 4 look like if we represent it, if we show it with a drawing? Okay, right. Well, what does it mean? Well, our number is 80 that we start with. Input 80. Times 4 means it's the same number 4 times. Our input number, I should have written, was 80. We start with 80, and times means that we end up, we're going to have that same number 4 times. Well, I got it one time. I draw another bar, another part of the bar, another box. So this is 1 time, 2 times, 3 times, 4 times, and it's the same number 4 times. Well, It starts with 80. It's 84 times, 1 times, 2 times, 3 times, 4 times 80. 80 times 4, we're going to use 8 times 4 is 32. 80, 8 tens times 4, 32, not 32 ones, 32 tens. We're making our answer 10 times bigger. 320. So our output is 320. Okay, good. Well, that's good. What about this one? This says that our input is 80, and now we are dividing. What does it mean to do 80 divided by 4? How do we represent that? Could you represent it with a bar model? Have a go. Well, I hope you paused the video. This time, it's 80. What does divided mean? Divided means split into, divided, split into 4 equal parts. Okay, well I know there's 4 equal parts because that's what divide by 4 means, so I'm going to draw them here. 1 part, look, I'm using the squares, 2 parts, 3 parts, and 4 parts. Well, all together, we started with our 80. The 80, we split it into, dividing means splitting into 4 equal parts. 1, 2, 3, 4 equal parts. 80 divided by 4, well, 80 is 8 tens. 8 divided by 4 is 2. 8 tens divided by 4 is 2 tens. Okay. It means 20 in each of the 4 parts. 80 divided by 4 is 20. Good. Well, we've revised some important things. Shall we get on to the slightly trickier questions? Now we understand. What does this say? We've got to calculate the input. Now look, the number that's missing now is the input number. There is a number. The rule is we add 13 to the number and our output is 29. Have a go. Have a go. Did you use a number line to help you to think about it? I'm going to. So I'm going to start always at the start of my number. The start of my calculation, I'm going to start with the input. So the input, well, I don't know what that number is, do I? It's the mystery number. So there's my input number. I don't know what it is, but I know that it's plus 13. So I'm going to still show that. Plus 13, like we did before. We add 13, and we know that our output number is 29. Now, what we need to do now is we need to think a number, add 13 gets to 29. Well, what do we need to do to go back? Because what we need to do now is to go back from 29 to the input number that we don't know. Well, we started with the input and we went forward 13. We've got to do the opposite or the inverse. So we've got to do, look, on this model, we're doing adding this way. But when we want to work backwards, we're doing the opposite, the inverse. So we're doing 29, take away 13, well, 29. Take away 10 is 19. 19 take away 3 is 16. And we can check it. Is 16 add 13 29? Yes, it is. So can you see, to get back to where we started, we use the inverse operation. The inverse operation. Okay, right, let's have a look at the next one. I wonder, what's happening here? Well, the input number, take away 13, gives us 29. I'll draw it. Are you going to try and represent it on the number line? Okay, let's do it. Well, I don't know what the input number is. Question mark. I'm going to show take away, and take away means go backwards on the number line, go down 13. The number, take away 13, gives us the output 29. And we now need to think about going back to where we started. Do you remember? We're going to do the opposite. We started on a number, went down 13. To get back where we started, we've got to add 13. We're going to do the input to output is take away 13. But when we work backwards, we are adding 13. To get back to where we started, we use the inverse. So let's do that. 29 add 13. 29 add 10 is 39. Add 3 is 42. 42 take away 13 is 29. Okay. Ooh. We've got a multiplication and division one here. So the number divided by 3 gives us 24. Well, remember, what does dividing mean? What does dividing mean? It means we've got to, remember we wrote this before, we've got to split the number into 3 equal parts. So the number is split into 3 equal parts. I'll show it like this. 1 part, 2 parts, 3 equal parts, and 24 in each part. 24 in each part. So what's the whole amount? The whole amount is 24 3 times. 24 times 3. 24 times 3. 4 times 3 is 12. 2 times 3 is 6. Add 1 is 7. So our amount is 72 divided by 3 makes 24. Here you see what we did. We did the inverse. The inverse of dividing, when we went backwards the other way, is multiplying. So, that's what we're learning about today. We're learning about inverse operations. We do the opposite going backwards. The opposite of dividing is multiplying. Let's have a look at this. So there is a number. When we have 3 times the same number, it gives us 60. Oh, I can draw that. So I want to draw the number. How many times is it that number? It's 3 times that number. That's what times 3 means. 1, 2, 3 times that number, and all together it's 60. Well, that means to work out what each part is, each of the three parts, the 60 is split into 3 equal parts. 60 divided by 3, because 6 divided by 3 is 2, 60 divided by 3 is 20. So our number is 60. Okay. Well, there's also a kind of puzzle here where we don't know what the rule is. We only know the input and output functions. So the input on this machine is 6. The output is 12. And here's Toby. Good old Toby. He looks cheerful. He says, 6? What happened to that 6 to make it into 12? 6, and we've got to find the operation. What was it? Well, Toby says the machine must add 6, because he knows 6 add 6 equals 12. Do you agree with him? Must it be 6 add 6 is 12? What do you think? Well, not really. You've got to slow down, Toby. Think carefully. You might need to see more than one example. Look, here the input is 6. The rule could be add 6, but is it going to work? Because the machine has now given us 2 more examples, and it's the same machine with the same rule. Well, 0 add 6 is 6, but the output here is 0. What happened? Let's look at this one. 4.5 in, 9 out. 6 in, 12 out. I've got it. It's not add 6, it's times 2. 6 times 2 is 12. 4.5 times 2 is 9. And 0 times 2 is 0, because 0 times anything is 0, and anything times 0 is 0. We know that. Pause the video, have a go. These 4 machines are all using the same rule. What is the rule, and what are the missing numbers? Pause it, have a go, see can you work it out. I hope you paused the video to have a go. Well, so my number is 6 on the input and 18. What's the relationship between 6 and 18? Well, 6 plus 12 equals 18. But 6 times 3 is equal to 18. So, could be either of those. Let me check this one. 9. I'll check my first one. 9 add 12. That's not 27. 9 add 12 is 21. I'll check the other one. 9 times 3. I think the rule is times 3. Because that works for both of them. Plus 12 doesn't work for both of them. What about this though? Half, we've got to use the same rule. Well, I think it's times 3. A half times 3, well, that means a half 3 times. A half and a half and a half. We've been working on this. We could write 3 halves, or we could say the first 2 halves make 1 whole, and this half left over. We'll put 1.5 or 3 halves. And our rule is times 3. Remember, it's times 3 this way. What will it be going backwards? The inverse. Not times 3, divide by 3. 90 divided by 3 is 30. Okay. Well, I hope that all makes sense to you. And we're going to show you some of your work. We've got this question, very similar question. And then we have some more of your work, level 1, level 2, level 3. have a go. If it's difficult to print things out, just write on a piece of paper, level 1, A, and then work it out and tell me what you think the output number is. Okay, see you soon everyone. Have a good go at it. Bye.